We can use the Bohr model of the atom to describe how the subatomic particles are arranged in an atom. For example, we have the nucleus in the middle of an atom containing the protons, which are the positive particles, and the neutrons. And then we have around that the different energy levels. And then in the energy levels, we're going to find what is known as orbitals. Now, the electrons are located in orbitals, and an orbital is just described as a volume in space in which there's a high probability of finding the electrons. Quantum numbers are just a solution of a mathematical equation, and we use the quantum numbers to actually describe that location of an electron. So we have four different types of quantum numbers, which we're going to see specifically what each one of them is representing. And then we can have a set of four quantum numbers to describe a specific electron. That's the very last thing that we do to review the quantum numbers and the relationship between the quantum numbers and the electron configuration. The electron configuration is the goal for this part because we want to go over where the electrons are located in an atom. Depending on how many electrons you have for a specific atom, we're going to have electrons in different energy levels, in different orbitals in those energy levels. We can see some of those energy levels represented here. Actually, if we have the nucleus in the middle, then we have different energy levels going around. And we use letter N, you will see what letter N represents. With N equals to 1, it's representing the first energy level, which is the one that is closest to the nucleus of the atom. And then we move to energy level number 2, energy level number 3, and so on. The energy is increasing as we move away from the nucleus. Here we have the list of the four quantum numbers. The first quantum number is known as the principal quantum number, and we use letter N for that one, which is the same letter N that I was using to represent the first energy level, second energy level, and third energy level in the diagram of the atom. The possible values for that principal quantum numbers, they start at number 1. That will be the first energy level, and they keep increasing all the way to 7. That's the maximum possible value for that principal quantum number N, which is 7. The second quantum number is the angular quantum number, and we use letter L to represent that one. If the principal quantum number N is representing an energy level, or what is also known as a shell, the angular quantum number L is representing a subshell. It's something that is contained inside of an energy level. The numerical value of L depends on the numerical value of N. We actually need to know which energy level is the one that we're looking at before we can find a numerical value of L. Then we're going to know other ways of finding the numerical value of L, not looking at the energy level, but looking at some other information. The possible values of L are given from 0 going all the way to N minus 1. So when we're looking at any energy level, the numerical value of L will never be equal to the same number that you have for the energy level. For example, if we're looking at the third energy level, N equals 3, the possible values of L can be 0, 1, and 2, because the maximum number for L is N minus 1. So if N is 3, the maximum number that you can have is going to be 3 minus 1, which is equal to 2. So the numerical value of N and L is never the same when you're looking at a specific energy level. The third quantum number is the magnetic quantum number, and for that one we use the symbol M sub L. In the same way that I need a numerical value for N in order to find out the numerical values of L, you're going to need the numerical value of L in order to find the numerical value of M sub L. The magnetic quantum number, we're going to have actual numbers representing all of your possible values, but the numbers by themselves are not giving you any information. The total number of digits that we're getting for that numerical value of M sub L is what is giving us the information that we need. You will see this when I do the examples for all of the quantum numbers. The possible values of M sub L, they start at minus L and they go all the way to plus L. For example, if you're looking at a numerical value of L that is equal to 1, the possible values of M sub L are starting at minus 1, going all the way to plus 1. So it means that you have minus 1, 0, and plus 1. And the last quantum number is the spin quantum number. We use the symbol M sub S for spin quantum number. It's just telling you the rotation of an electron. So for the spin quantum number, we have only two possible values. It can be positive 1/2 or negative 1/2. So let's review the quantum numbers and let's find out the possible values for some of the quantum numbers. I'm not doing M sub S right now. We're going to do some examples for M sub S a little bit later. So we have different energy levels. Actually, there are 7 possible energy levels, and we can relate the energy level to the periodic table. On the periodic table, we have 7 periods, and the periods are the ones that are going across the periodic table. So from left all the way to the right side on the periodic table. So there are 7 of them, and actually each period on the periodic table is representing an energy level on an atom. So I'm listing just 4 energy levels. That's more than enough for what we're trying to do. So for my first energy level, numerical value of N, which is the principal quantum number, is equal to 1. If we want to find out the numerical value for L, numerical value for L starts at 0 and it goes all the way to N minus 1. Those are my options for L. 0 all the way to N minus 1. If the energy level here is the first energy level, the numerical value of N is 1. So when you type 1 here, that will be 1 minus 1, which is equal to 0. So when you're looking at the possible values of L on the first energy level, we have only one possible value, which is 0. If the value of L starts at 0 and it goes all the way to N minus 1, you have 0, N minus 1 is 0, so there's just one possible value. When you're looking at the second energy level now, the numerical value of L starts at 0 and it goes all the way to N minus 1. So N minus 1 in this case is going to be 2 minus 1, which is equal to 1. So the maximum number that you can have for L in this case is going to be 1. So the numerical values of L when the energy level is 2 is 0 and 1. Starting at 0 and going all the way to N minus 1, which is equal to 1 in this case. When we move to the third energy level, again starting at 0 and we go all the way to N minus 1. The value of N is 3. 3 minus 1 is 2. So that's the maximum value. So we're going to have 0, 1, and 2. From 0 all the way to n minus 1. For the fourth energy level, again, we start at 0. That's always the first value for L. And we go all the way down to n minus 1. N minus 1 is equal to 4 minus 1 because that's the numerical value of n. 4 minus 1 is 3. So my numerical values of L, they start at 0 and they go all the way to 3, which is n minus 1. So it's 0, 1, 2, and 3. Now, something that you should notice here is that my numerical value here, it's 1. That's my first energy level. And on the first energy level, I have just one possible value of L, which is 0. On my second energy level 2, and I have two possible values of L. When I'm looking at the third energy level, I have energy level 3, and I have three possible values of L. And for the last one, I'm looking at the fourth energy level. I have n equals to 4, and I have four possible values of L. So the number that you have for the energy level is actually telling you how many possible values of L you're going to have for each of those energy levels. Now, the numerical value of m sub L is given from minus L going all the way to plus L. When the energy level is equal to 1, you have only one possible value of L, which is 0. Always starting at 0, going all the way to n minus 1. So we have just 0 here. There's no such thing as a negative 0 or a positive 0. It's just 0. In this table, anytime that we have a 0 listed, the possible value of m sub L, it's always 0. It's the same thing. The value of m sub L is given by minus L going all the way to plus L. If the value of L is 0, you have just one possible value of m sub L, which is 0. It doesn't matter where the numerical value of L equal to 0 is located or in which energy level. If L is 0, m sub L will always be 0. Now, on that second energy level, we have a numerical value of L that is equal to 0, but we also have a numerical value of L that is equal to 1. When the numerical value of L is equal to 1, the values of m sub L, they start at minus 1 and they go all the way to plus 1. So my possible values of m sub L here are minus 1, passing through 0, and to plus 1. So I'm starting at negative 1 because the numerical value of L is 1. So from minus L, which is 1, all the way to plus L, which is positive 1. So in the table, anywhere that you have 1 as the value of L, the values of m sub L are going to be exactly the same. Now on my third energy level, besides having an L value equal to 0 and 1, I also have an L value that is equal to 2. So the possible values of m sub L are going to start at minus 2 because we go from minus L, which is 2, all the way to plus L, which is 2. So we start at minus 2, minus 1, 0, plus 1, and plus 2. Which means that in this, L equals to 2 on the fourth energy level. We have exactly the same thing. So we're just missing one more here on the table. When the numerical value of L is equal to 3 on my fourth energy level, my possible values of M sub L are starting at -3 and are going all the way to +3. So I mentioned that the actual numbers that you have, they are not important. If it's a 0, if it's a -1, if it's a -2, a +2, +3, that's not the important part. The numerical values of M sub L are actually telling you how many orbitals of a specific type of orbital we have. We're going to have orbitals, right? That's where the electrons are expected to be located. And those orbitals are going to be in the different energy levels. So we're going to have a specific number of each type of orbital in the different energy levels. And that specific number for each type of orbital is given by how many possible values of M sub L we're actually obtaining. So here we have the same table as before, but we're adding some other information. I still have my 4 energy levels, and 1 and 2 and 3 and 4. We determine the possible values of L for each energy level. We determine the possible values of M sub L for each possible value of L. Now, the number of orbitals here is given by how many possible values of M sub L I have listed. Not by that number, but by how many digits we have listed. So when I'm looking at the first energy level, numerical value of L is equal to 0. Possible value of M sub L is just 0, one possible value. One possible value means that you have one orbital. Every time that you have L equals to 0, M sub L is equal to 0. So in this table, anywhere that you have a 0 only listed, that's the same thing. One possible value means one orbital. When we look at L equals to 1, you have 3 possible values, -1, 0, and +1. 3 possible values means that you have 3 orbitals. Anywhere on the table in which you have and where you have 3 possible values, the number of orbitals is equal to 3. On the third energy level, right, we have 3 possible values of L, 0, 1, and 2. So when we're looking at the possible values of M sub L when L is 2, we have actually 5 digits listed, 1, 2, 3, 4, and 5. 5 possible digits means that we have 5 orbitals. Not just on the third energy level, but on the fourth energy level, we have a numerical value of L equals to 2, which is going to give you from -2 to +2 as the possible values of M sub L, which is 5 digits, which is 5 orbitals. And then we're just missing numerical value of L equals to 3 on the fourth energy level. When we determine the numerical values of M sub L, we start at -L, which is 3, and we go all the way to +L, which is 3. So we have -3, -2, -1, passing through 0, 1, 2, and 3, which is 7 digits. 7 digits means that we have 7 orbitals. Now, the actual numerical value of L is telling us a specific type of orbital. You can check that there's a limited number of values for L. We have 0, we have 1, we have 2, and we have 3. Just those 4 possible values. Each value is actually represented by a letter. When the numerical value of L is equal to 0, it means that we have what is known as an s orbital. When the numerical value of L is equal to 1, we have a p orbital. So we can actually write down s everywhere that we have L equal to 0. And we can actually write down the letter P everywhere that we have L equals to 1. It's always the same. If L is 0, we have an s orbital. If L is 1, we have p orbitals. If L is 2, we're going to have d orbitals. And then when L is 3, we have f orbitals. We have those 4 types of orbitals. There are other orbitals, but these are the ones that we're going to use in the class. We have s orbitals, p orbitals, d orbitals, and f orbitals. We have a specific amount of orbitals for each one of them. Numerical value of m sub L equals 0 means that you have 1 digit, 1 orbital. If you have m sub L 0, it's because L is 0. So when L is 0, you have an s orbital. For an s orbital, we have 1 s orbital. Every single energy level is going to have s orbitals, all of them. You can see it on the table. L0, it's on the first, second, third, and the fourth energy level. So if you have a numerical value of L equal to 0 in all 4 energy levels, it's because you have an s orbital in each one of them. Now on the second energy level, you have the s orbital, but you also have a value of L that is equal to 1. Whenever L is equal to 1, we have p orbitals. You can check. L1, p orbital. L1 here, and then we have p orbital. L1 here on the fourth energy level, and we have p orbitals. P orbitals, we have 3 possible values of m sub L, 3 possible values of m sub L, here 3 possible values of m sub L. It means that everywhere that you have a p orbital listed, you're going to have 3 of them. We don't have d orbitals on the first or the second energy level. We start having the orbitals on the third energy level. You have a possible numerical value of L that is equal to 2. When L is 2, we have d orbitals. Now, the possible values of m sub L, you have 5 possible values of m sub L. -2, -1, 0, 1, and 2. 5 possible values is telling you that you have 5 orbitals. So since L, we're looking at L equals to 2. L equals to 2, it's a d orbital, and we have 5 of them. So on the third energy level where you have d orbitals, we have 5 of them. On the fourth energy level where you have d orbitals, you have 5 of them too. And then the very last one, which is the f orbitals, we only have those here listed on the fourth energy level. So when you have an L value equals to 3, we have possible values of M sub L starting at -3, ending at +3. That's 7 possible values. 1, 2, 3, 4, 5, 6, and 7. We have that number right here. That number means that you have 7 F orbitals. So we have S orbitals in all 4 energy levels, and we have only one of those S orbitals in each energy level. We start having p orbitals on the second energy level, on the third, on the fourth. In all 3 energy levels containing p orbitals, we're going to have 3 of them. D orbitals, we have them for the first time on the third energy level. For the d orbitals on the third energy level and on the fourth energy level, we're going to have 5 of them. And then the very last one is the f orbitals, which we have on the fourth energy level, and we're going to have 7 of them. Let's do a couple of examples about the quantum numbers. So the first question here is just asking how many orbitals you have when n is equal to 3. First of all, you need to be aware of what n equals 3 represents. When you have n equals 3, that's talking about the third energy level. How many orbitals do you have? If n is equal to 3, to find out what type of orbitals you have, you need to know the possible values of L. So if n is 3, the possible values of L are 0, 1, and 2. Value of L starts at 0 and it goes all the way to n minus 1. So I have my 3 possible values. The value of L is actually telling you the type of orbital. When L is 0, your orbital is S. When L is 1, your orbital is P. When L is 2, the orbital is D. S orbitals, we have 1 of them. P orbitals is always 3 of them. D orbitals is always 5 of them. The number of orbitals that we have for each type is given by the amount of digits that we get for the M sub L quantum number. If L is 0, M sub L, you have only one possible value, 0. One possible value is telling you that there's just one S orbital. When L is 1, M sub L is -1, 0, and 1. That's 3 possible values. That's telling you that we have 3 p orbitals. M sub L, when L is 2, is -2, -1, 0, 1, and 2. 5 possible values. I have 5 possible digits here, which is 5d orbitals. So on the third energy level, in which we have s, p, and d orbitals, we're going to have a total of 9 orbitals. Another way is just doing the numerical value of n squared is going to tell you the total number of orbitals that you have in that specific energy level. If we look at the second energy level, n is equal to 2. 2 squared is 4 orbitals. You have on the second energy level, you have an s orbital and you have 3 p orbitals, which is giving you a total of 4 orbitals. If you want to find out the numerical value of M sub L, it goes from -L all the way to +L, which means that we actually don't look at the numerical value of N. I have a numerical value of L here that is equal to 1. So possible values of M sub L is -1, 0, and +1. The word subshell is actually telling you the orbital, right? The shell or the level is the energy level, and then in each energy level we're going to have the sub-levels or subshells, which are the orbitals. On the first energy level we have just one subshell, which is the s orbital. On the second energy level we have two subshells or sublevels, which is your s and your p orbitals. So when we're looking at this 4D here, this number is telling you the energy level. This number here, which is the shell, is telling you the type of orbital is D. If you know the type of orbital, you also know the numerical value of L. Remember, when L is 0, you have an s orbital. When L is 1, you have a p orbital. When L is 2, you have d orbitals. So it works the other way around too. If you're looking at a d orbital, it's because the numerical value of L is equal to 2. So for this question, the numerical value of n is 4. Is the number that you have right there listed. The numerical value of L is given by the type of orbital. We did that right here. When the numerical value of L is 2, you have a d orbital, which means that if you have a d orbital, it's because the numerical value of L is equal to 2. Now, to find out the possible values of m sub L, you need to know the value of L, which is 2. I know we went over a lot of information, specifically about the quantum numbers. But the focus of this topic is to actually give a location for the electrons in an atom. It's just that the location of the electrons is actually given by those quantum numbers. So we know that we have 4 types of orbitals that we went over: s, p, d, and f orbitals. Those orbitals are the subshells or sublevels that are contained in the different energy levels that we have in an atom. So we have energy levels listed from 1 through 4. In each energy level, we have the different sublevels or subshells, which are the orbitals. We also know that we have different number of each type of orbital. Whenever we have an s orbital, we're going to have one of them. P orbitals is always 3 of them. D orbitals is always 5 of them. And then F orbitals is always 7 of them. So we're going to use that information to write down the electron configuration, which is just telling you, right, in which energy levels we have electrons, and also in which specific type of orbitals we have electrons. Now, the number of orbitals that are going to be occupied with electrons in the different energy levels is going to depend on the total number of electrons that we have for a specific atom. So just to go over some of the information that you have here. Look. All of the numbers that I'm highlighting are energy levels. So if I have electrons here, it means that I'm going to have electrons on the first energy level in an s orbital. S orbitals we have on the first energy level, second, third, fourth energy level, fifth energy level. In all energy levels that we have listed, we're going to have S orbitals. I have a letter, right? I have one SX, and you can see that everywhere that I have an S, I'm using the same letter X for all of them. Then when I have P, I have letter Y. And then when I have letter D, I have Z. And I'm using the purple for that one. That letter X, Y, and Z is actually representing number of electrons. So we're going to arrange the electrons in an atom in these different energy levels in the orbitals that we have in each energy level.